Hello, everyone. Today we are going to be going over the projectile and forces explainer problem that I was assigned this week. So I'm going to just quickly pull this up here. I'll share the screen. Let's scroll to the top. Alrighty, so for this problem, it states that a rock is fired at ground level with an initial speed of 46 meters per second at an angle of 25 degrees above the horizontal. It hits a point above the ground 2.8 seconds later. So first, before we even look at what part A is asking us, we need to draw a picture. And here I've labeled my X and Y axis, and then I place put the degrees above the horizontal as well as the magnitude velocity here of the rock as it is fired. And then also a strategy I like to use before I even start the problem is just list our knowns and unknowns, kind of like the same we do in just like a lecture or our Zoom meetings. So as you can see here, I have put down all the variables, and we do not know X and Y, which is our final horizontal and vertical position. We don't know those. As we'll see, these are the two variables that we're going to be solving for in this problem. Our initial positions of X and Y are just 0 because that's just our origin of our axis here. Our final horizontal and vertical velocity, we don't know. We also don't know V naught X and V naught Y, which is our initial velocity. We do know acceleration because it is constant, it's just the force of gravity, which also makes it negative because it's pointing down. And we do know time, 2.8 seconds, because it was just told to us in the problem. So part A asks, what is the horizontal distance in meters from where the rock was fired to where it hits the point? So for this problem, as I said, we're going to be solving for X, which is our final horizontal position. So first, we need to use the magnitude and direction to find our X component, V naught X, because that'll allow us to use the formulas to solve for the final position. So the formula we'll be using is this one right here. And it'll be using cosine of the angle, and you have to make sure it's cosine and not sine, because sine is for the Y component, and that could just mess up the whole problem right at the start. So you want to make sure you're careful which trig you use here, which kind of trig you use. So, and as you can see, I just plugged it in here, and it gives you 41.69 meters per second. So next, you can use an equation to solve for X because we were given the time in the initial problem, as it stated. So you're going to just plug into this formula right here. And then if you just do this, it's pretty simple algebra. You don't even have to rearrange the equation. You get 116.7 meters. Next, in part B, it asks what is the vertical distance in meters from where the rock was fired to where it hits the point. So also, just like last time, you just want to list your knowns and unknowns. So everything's the same except for now we know our final horizontal position as well as V naught X, because we just calculated those two. But now we just want our final vertical position. And we also don't know V naught Y, which is what we will solve for right now. So again, just use the magnitude and direction to find the Y component now. And so you'll insert the angle here, and just it's the same equation except cosine is switched with sine, and you just want to make sure you get those straight before you do the calculation. And then for this, you'll get 19.44. And the next, you solve for Y using a different equation because you know these four variables right here. You're given those, and you can just figure those out from just knowing the problem. Like for example, why not here? You just know is 0. You just calculated this, and you're given these two, and you can infer the acceleration as I stated previously. So this is the equation you'll be using, and you can just, again, you don't even need to rearrange it. You can just plug in the variables here, and you want to make sure you have a negative 9.8 because it's very easy to forget that it is negative. And also, if you're putting this in like your calculator, you want to make sure you put the squared on the 2.8 because it is squared here, and you want to make sure it's just in parentheses for extra, just to be extra safe. It doesn't mess up the equation, because that's happened to me on like multiple occasions. So if you plug it in correctly and you do the algebra correct, you will get 16.02 meters for your final answer for the Y. I'm going to stop saving this here. Alrighty, so that is how you work through that problem, and thank you all for watching.